Alright guys, question 5. This is CAS at its most CASiest. They've thrown the CAS book at us and we have to weather the storm, alright? So, let's go for this. It's pretty gruesome. F is this beast, right, and G is this beast here, alright? Two different functions. First of all, we have to express this in the form of that. So, what the? Well, look, it's not that bad. If you just keep your head, you can actually get to the answer without too much trouble at all. When I first saw this and tried to digest it, I thought, goodness, well, I'm probably going to have to expand all of this and then do some equating of coefficients and then compared to this and then solve some simultaneous equations to get the answer. And that's in fact the way I've done it here. But there is actually a quite nifty little way of doing this by hand for 2 marks. And that is, if you take x out of this, you'll get x into x cubed minus 8. And happily, x cubed minus 8 is a nice little whole number difference of 2 cubes. And if you remembered that from year 11 methods, you would be laughing because you know that x cubed minus 8 is x minus 2 times x squared plus 2x plus 4. And that would have the whole thing. You'd have the whole thing, then all you'd need to do is just take that x squared plus 2x plus 4 and factorise it in this form by completing the square, and you'd be laughing, you'd have it. But if you didn't see that, then this is the way you would go. You'd get your CAS going, you'd put this function into your CAS handheld like that, you'd expand it out like that, you'd have a great big mess, and then you'd basically try to collect those like terms, and you'd get this, and you'd equate it equal to x to the 4th minus 8x. So you'd have x to the 4th plus this beastly looking thing x cubed plus this also beastly thing times x squared plus this thing times x. And then what you've got to do is equate the coefficients so that this thing here, there being no x cubed term over here, would be nothing. This one here, the x squared term, would be nothing. And this thing here would be minus 8. And you would solve that very quickly on your CAS. That's right, and that's right. Now, just get the CAS out. Don't try and solve that by hand. It's only 2 marks, guys, and you're in a hurry. So, do that. Solve that thing, that thing, that thing, solving it for A, B, and C, and look, it spits out a beautiful answer for you. And then you just put it like that, and you've got it. Okay, that's 2 marks. So we've got that one done quite successfully. Alright, next bit. Describe the translation that maps the graph of f of x onto the graph of g of x. Alright, let's put them both in this similar format, okay? So f of x was this thing here, and g of x in our newly found format is this thing here. So we've got to work out what would you need to do to transform this beast into this beast here, okay? Now, looking at it in that light, it's not that bad, and I think this is the most instructive part of it here. See this is turning into that. You can see that, can't you? So it looks like we're replacing x with x plus 1. Now, see if that works in the other 2 terms. If I replace that with x plus 1, that'll become x plus 1 minus 1, which would just become x, aka this beastie. And this one here, x plus 1 minus 3 would become x minus 2. Yes, we've cracked the code, guys. We've cracked the code. So we're replacing x with x plus 1, which means that we're really doing a translation of 1 unit to the left, isn't it? I think so. So I've done this fairly formally for you here. I'm calling g of x the translated function, so I'm putting x dashes in here. That's the way I always do them anyway. So we're saying if x squared plus 3 transforms into this, that's just this part of f of x transforms into this part of g of x, alright? Where I'm saying that x prime plus 1 is equivalent to x, and therefore x prime is x minus 1, and that's basically the nub of it, guys, okay? We're going 1 unit to the left, so therefore if we substitute, checking that I've got that for the rest of it, f of x becomes that thing there, which is what I was explaining to you, and that looks right. Okay, so therefore we're right, and we can say that if x prime equals x minus 1, we have a translation of 1 unit in the negative x direction. That's the way you want to write it, guys. Don't say 1 unit to the left. So we have a translation of 1 unit in the negative x direction to get your marks, alright? Alright, next bit. Find the values of d such that the graph of y equals a function of x plus d has one positive x-axis intercept. Now, I think this is a bit cruel at the end of an exam. It's a 1-mark question, so it's not so bad, but it's really an exercise in clear thinking when you're under duress and this is the last question in the exam and you're probably running out of time. Now, let's write it out. F of x equals this thing here. Now, alright, so therefore the x-intercepts are going to be at x equals 1 and x equals 3. Okay, now, you've got to think about this, where we've got 2 positive x-intercepts there. We're only allowed to have 1. So we better move this graph. We translate this graph so that we knock out one of those intercepts and keep the other one. That's what we've got to do. So I suggest we should move this graph to the left. Wouldn't you think so? So if we have y equals f of x plus d and we have one positive x-intercept, okay, that's what we asked for. Basically, if we move the thing 1 unit to the left, then we've got one intercept is right on the origin, which is not positive. There remains this one here, right, which is now sitting at x equals 2, isn't it? Yeah? Just to get our picture clear on what's going on. But if d equaled plus 1, we've knocked out one into positive x-intercept and we've got one left, okay? So that's all right. So that's the first part of the puzzle. D equals 1, we'll do it, okay? Now, if we move further than that to the left, if we move a total of 3 units to the left altogether, there'll be none left, okay? So that knocks out everything. So therefore, what values of d are acceptable? Being extremely careful to get this right. That one's d equals 3. We know that d could be 1, yes, and d could be greater than 1, yes, but it can't be as far as 3. It can be everything up to, but not including 3, because when you include the 3, you knock out the other positive x-intercept. So that's the answer to that one, guys. Alright, now the next bit. Now we want 2 positive x-axis intercepts for 1 mark again. Now this is also a case of getting your head clear so that you can think when you're at the end of the exam and you're just about at the end of your tether. So 2 positive x-intercepts. The best way for me to explain this is to put this little statement here. From this thing that we got up here, remember that if d was anything greater than or equal to 1, including even now greater than 3 or equal to 3, okay, everything equal to or above 1, we will get what we said here, 1 positive or even 0 positive x-intercepts, okay? So there it is. From above, if d is greater than or equal to 1, we have either 1 or no x-intercepts. And therefore, for everything else, guys, that makes it easy for us to see. For everything else, we can get 2 positive x-intercepts, because there's our function up there, all right? So therefore, all we need to do is express that in this way. We can see that if d is less than 1, we'll have 2 positive x-intercepts, that is. This should be saying positive x-intercepts, moving the graph to the right from d equals 1, and therefore we know that d can be anything from minus infinity up to, but not including, 1. Now there is another way that you can do this, and that's via a picture, e.g. a little graph, because a picture is always worth 1,000 words. So if your mind is getting fuzzed in the exam and there's not much time left and you really need to think clearly, you could sketch yourself out a little graph very quickly. And what I'm showing you here is this is the number of positive x-intercepts, and this is the value of d. Now I'll just put a bit more detail on this for you. Now you wouldn't need to put all this detail when you were just sketching this on a spare space somewhere on your exam paper, but just to show you. Now what you would do is you're dealing with this, okay? It's where d is the translation of this graph here, okay? Horizontal translation. Now just put a few points in. If d was 3, okay, you would have this situation, you would have no positive x-intercepts, because you'd know that the right-hand most x-intercept of this function here would have now moved over to be sitting on the origin. So you've got no positive x-intercepts left, alright? Now another value. You know that if d was 1, you would know in that instance that you have moved over to the left 1 unit, and therefore the right-handmost positive x-intercept, which was sitting on 3, would still be in the positive, but the intercept where x was equal to 1 would now be sitting on the origin, therefore that one's knocked out. So you've got this situation here. Do you see what I'm doing? I'm building up a picture. If d was 2, you've still got 1 positive x-intercept, but one of them is the one where x was equal to 1 is now over to the left of the y-axis. Okay? Get that? What about if d was 0? Well, if d was 0, you've got this one and you've got that one still in business. There's still, that one's at x equals 1, this one's at x equals 3, so you've got 2 positive x-intercepts. Try a few more values. If d was minus 1, well, that's effectively moving the graph over to the right, so you preserved your 2 positive x-intercepts there, and in fact for any negative value of d that's the case. You can see, now you start to build up the graph. There it is, okay? So you can see you've got 2 positive x-intercepts where you've got anywhere along this line, okay? But where d is 1, you immediately knock yourself down to 1 positive x-intercept, and in fact along this line now between 1 and 3, but not including 3 because 3 is a solid dot down here, you've got 1 positive x-intercept, and in fact for anywhere 3 and above you've got 0, okay? 0 positive x-intercepts. Do you see? So there it is. You've got 2 positive x-intercepts there where d is in that domain, okay? You've got 1 positive intercept when d is in there, and you've got 0 positive x-intercepts where d is from 3 inclusive up to infinity. Okay, so that might help you. You can sketch that out fairly quickly just by drawing a little picture and picking specific values of d. It might clear up your mind. Alright, next bit. They haven't finished with us yet, guys. They're going to kill us if they can. Find the value of n for which the equation of g of x equals n has one solution. So this is not equal to 0 has one solution. This is g of x equals to n, the value of n for which this thing has one solution. So if you were to draw a horizontal line at y equals n, it would touch the graph once, is the best way of thinking about this. So there's g of x. There's a little bit of CAS help for you, okay? So what I'm looking for is the value down here where a horizontal line from the y-axis over touches the graph only once. So we're actually looking for the minimum value, okay? The minimum value of the graph here, the y-coordinate of the minimum value of the graph. So if you can get that far, you're laughing because you know what to do. So you can get the y value of the stationary point, or that's using CAS, or you can do the following. If you express g of x the other way that they expressed it at the beginning of the question, just like that, that's actually pretty easy to solve for the stationary point and therefore the value of y at that stationary point. So see that? G dash of x would equal to that. Now if you solve that for 0, this is doing it manually, you get that, therefore x cubed is going to be 2, therefore x is going to be the cube root of 2. And if you plug that back into the equation for g of x, it's going to be that thing there, which will get you, without too much trouble, what I've done there, just have a little look at that, that's pretty nifty. I've just basically factorised out 2 to the third out of both those terms, right? So therefore what I get there is minus 6 times 2 to the 1/3, which is the correct answer. Alright? Nice, huh? Alright, part E. At the point u, g of u, the gradient of this function here is m, and at the point v, g of v, the gradient is minus m, okay, the negative. Where m is a positive. Okay, we better remember that. Positive real number. Okay, look at this. Find the value of u cubed plus v cubed when your head's already fried for 2 marks and you've got like 2 marks 2 minutes before the end of the exam. Never fear, we'll push onwards, guys. Have courage. So you look at this and you think, well, what am I supposed to do here? what you do is you use the clues and you just put one foot in front of the other and see where you end up. That's what you do, because you're more likely to see what to do if you just do something. So, alright, there's g of x. Okay, we're looking at gradients. So let's work out the gradient, shall we? There it is. Now let's substitute our value of u in, and we get that, and apparently the gradient's equal to m. Well, there's something. That looks like something. Not sure yet. Well, don't worry, we'll see it in a minute. Let's do the same thing for v and see where that takes us. So we know that g dashed of v would be 4v cubed minus 8, and apparently that's equal to minus m. Now, look, guys, can you see, look, this thing here, right? Well, look, there's a u cubed, there's a v cubed. So why don't we just bite the bullet and add these two equations up, and then that should get us what we want, I think. So there you go. Oh, look at that. Look at that. So therefore, if you take that minus 16 over the other side by adding 16 to both sides, you're going to get that, and then if you divide both sides by 4, we've got it for 2 marks. That's so good, isn't it? Alright, we've got this far. Let's keep going. Find u and v if u plus v equals 1 for 1 mark. Well, that can't be too hard. Remember, the answer's never very far away, guys. We already know that, don't we? Yeah, as the story unfolds, remember, you've got to keep track of the story as it unfolds. So we've got u cubed plus v cubed equals 4. We've also got that u plus v equals 1. We've got 2 equations, 2 unknowns. Surely we can solve that for u and v, can't we? So there we go. So if you do it on the CAS, just to stop all the mucking around, because it's the end of the exam and you're tired as, you've got this, solving for that. Oh, goodness. Now, guys, is this the end of the story? Is it this and that? Are they both right, or is one right and not the other? So this is time to really get your thinking cap on and think about, goodness, remember that m, do you remember back in the earlier parts of the question we had that m was a positive number, right? So think about this. Look, g dash u would have to be positive, because remember g dash u equaled m, and m was greater than 0, okay? Now, by the same token, g dash v has to be negative, because g dash v was minus m, alright? So we're trying to work out whether u is the bigger number or v is the bigger number, because I think one of these, this one might be right or this one might be right, but not both of them, okay? So let's just pursue this a little bit further. Let's have a look at the graph. Over the screen we go, okay? Remembering that g dash u, the gradient at u is positive and the gradient at v is negative, alright? Now there it is there. This part of the graph has a negative gradient, this part of the graph has a positive gradient, so therefore you can see, guys, that therefore u would have to be greater than v if the gradient of the curve at u is plus m. So u has to be bigger, because it's over this part of the curve, compared to v, which must be in here somewhere, okay? So therefore u is the bigger number, so therefore u has to be the bigger one, 1 plus root 5 over 2, and v has to be 1 minus root 5 over 2, and that's the answer. That was a lot for a 1 mark question. Alright, next bit. This is, F is the last part. I think there's a part 2, which is a knockout punch. But this is part 1 of F. Find the equation of the tangent to the graph of y equals g of x at the point P and g of P. Yeah, that looks alright. No problem. We've got g of x in its simpler form is that, therefore the gradient would be that. Therefore substituting the point P in, we'd get an actual gradient at a point P of that. Now we'll just go for the equation of a straight line, a tangent line, which has a gradient of that specific value going through that specific point, where this is that m is this thing, and x1 is our known point P, and y1 is our known point P to the 4 minus 8P. Substitute all that in, you get a great big mess. Try and simplify that a bit, and we multiply those brackets out, we get that. Now, goodness, what a mess. Is there anything going to... Oh yes, there is something going to cancel out. There we go. So therefore we get that, and therefore y equals... yes, right. There's our answer. If you simplify that, you get the thing in the blue box. Alright, so that's that one done. Alright guys, this is the end. This is the knockout punch, the VCAA king hit. Find the equations of the tangents to the graph y equals g of x that pass through the point with coordinates 3 over 2 and minus 12. In fact, that's for 3 marks, guys, and I would doubt whether many people would have got this right because they would have run out of time or run out of brain or both. So let's start with where we finished last time. As the story unfolded, we had this equation for the tangent to the graph of y equals g of x at a specific point of touching the graph. The tangent touches the graph at the x value of p. Okay, so once you have a value of p, then this is your tangent line. This is the relationship between y and x. Once you've got a value of p, then this straight line equation rule applies, where you can choose x as your independent variable and y will be the dependent variable according to this rule. Okay, so just getting our heads around that, because we've got CAS City here with pronumerals everywhere. Alright, now having a look at the question again. This is a value of x and this is a value of y on that tangent line. This is basically nothing to do with p. This is just an x independent variable, and this is then the dependent variable which pops out of the rule for a tangent line. Okay, now they're asking us for the equation of the tangents to the graph of y equals g of x which pass through this point. So apparently there is more than one tangent which basically pass through this value of x and this value of y. Okay, now hark back to our equation for the tangent here. Look at this. If this 3 over 2 is my x on the tangent line and this minus 12 is my y, then have a look at this equation. The only unknown I've got here then in this equation for the tangent line is my p, which presumably I can solve for to find the point at which the tangent line touches g of x. Okay, that's what we're trying to do. If we can get that value of p, that specific value of p, and apparently there'll be more than one because they're asking for tangents, then we have the actual equation without the p pronumeral in there driving us all crazy for the tangent line. We have the rule for the tangent line. Alright, so what we're going to do is we're going to substitute x is 3 over 2, y is minus 12, and we're going to solve for p. And once we do that, as I was saying, we can substitute those specific values found for p into this equation and we can get at the tangent line equations, which is what they're asking us for. Okay, and we'll use CAS for that. That's our game plan. But it does take a bit of getting your head around at this stage of the exam when you've got pronumerals all over the place and your head's in a fog. Alright, so here it comes. Now, what I did was I put this here into my trusty CAS handheld as f1 of x, right? Then I solved the whole thing with x here and y there, and I solved it for p, and look what popped out here. I just got this beautiful answer which gives me great confidence to know that I'm on the right track. So p is 0 or p is 2. Now what I'm going to do with that, guys, is I'm going to substitute each of those values of p in turn into this using CAS, and I'm going to get two lovely equations for the tangents. So if I substitute p as 0 into f1 of x, right, I get this. So y is minus 8x is one of my tangent lines. And if I substitute p as 2 into the same thing here, the same equation, I get y is 24x minus 48. So that gives me two tangent lines, okay? And those tangent lines apply to those two specific values of p which we just solved for. And that, ladies and gentlemen, is it. We survived the VCAA King hit. Now if you weren't still sure about that, let me just show you a picture, a graph of this, which I prepared for you just to clarify it beyond any measure of doubt. And by the way, you weren't required to do this, but I decided to do it just for interest and to show you and to help your head. Okay, there it is. Now there is the whole story. This pinky looking line here is g of x, alright, and this point here is where x is
3 over 2 and y is minus 12, okay? And here are the two specific values of p that we solved for, okay, for the equation of the tangent line. These are the points where the tangent line goes through this specific point here, and these are the values of p, and p, remember, is the value of x where the tangent line touches the curve, okay? So if it touches it where x is 2, it just happens to coincide with the x-intercept, the right-handmost x-intercept of g of x, very cunningly, and also where p is 0, that is x is 0, that is the point where the tangent line touches the curve at the left-handmost x-intercept of g of x. So it's very amazing. This question has been craftily prepared so that it would come out beautifully like this. You see? So there are our two values of p. P is 0, p is 2. It just so happens that for g of x, the x-intercepts are x is 0 and x is 2, and here is the point at which those two tangents intersect. Okay? So that's it, guys. That's we survived. Okay? We survived, and how. I hope that really helps you. That's VCAA and CAS at its most CASiest, and you can do it if you just keep your head and do plenty of practice in the meantime before you hit that exam. All right, well, thank you for coming, and all the best to you.